Hi, welcome to Learning Monkey. I am Raghu here. In this class, we will discuss about equivalence of predicate formulas. So this is very easy to understand. In our previous classes, we already discussed about equivalence of proposition formulas. There we have discussed that we say that two formulas are equal. When we are going to say that two formulas are equal, if their truth tables are equal, means for both the formulas, if you got the same truth values, then we say that the two equations are equal. So the same way we can show that both the truth values are same, but here in the explanation we'll take an example and understand why these two formulas are equal. Without taking the truth table, we are going to explain it. That is the best way to understand, because we are going to use these equations in our coming classes. So coming to the first equivalence formula, not for all x a of x. This is equal to there exists x not a of x. See how this formula looks like. In order to remember the formula very quickly, for all x converted to there exists x, not went inside. There exists x, not a of x. This is how the equation is. Now try to understand with an example why these two formulas are equal. Let's take in place of a of x, we are taking d of x. Means x will die, x is going to die. That is what our predicate equation is. Now take the formula not for all x d of x. What's the meaning of this? Without this not, what's the meaning of this? For all x d of x means you take any x, x is going to die. Not for all x d of x, what's the meaning of that? Not for all x d of x means there is at least one x who will not die. That is what the meaning of this equation. Not for all x d of x means there exists at least one x who will not die. The meaning is same. There exists at least one x, not d of x means x is not going to die. So that's why these two equations are same. Hope you understand. You listen this conversion again if you don't understand. Now coming to the second equation, not there exists d of x. It is equal to for all x not d of x. The same way there exist has converted into for all x, negation went inside. So what's the meaning of this? X, there exists x d of x. What's the meaning of that? At least one x is there, that x is going to die. Not there exists x d of x means you cannot find any single x who is going to die. Means not there exists d of x means everyone will live forever. You cannot find an x who is going to die. What's the meaning of that? Means all x are going to live forever. They are not going to die. So this can be written, this statement is same as for all x not d of x. What's the meaning of that? X is not going to die. This is applicable to for all. Means everyone is living forever. They are not going to die. So that's why these two equations are same. Now coming to the next one, for all x a of x and b of x. See, for all x is applicable to this entire equation. This is equivalent to for all x a of x and for all x b of x. Why this is equal? For all x means you take any x, that x has to satisfy this equation, means a of x has to be true and b of x has to be true. Then only this entire equation is going to be true. It should be true for all the x values. That is what the meaning of this equation. Then only this entire equation is going to be true. The same meaning you are going to get here also. For all x a of x, this equation is going to be true if you take any x, it has to satisfy for all the it has to satisfy a of x for all the x, then only this equation is going to be true. Yes, and for all x, b of x means you take any x, it has to satisfy b of x, then only this entire equation is going to be true. This entire equation is going to be true if this is true and this is true. Same as this. Take the next one, There exists x, a of x, disjunction b of x. It is equivalent to there exists x, a of x, disjunction there exists x, b of x. The same way you try to think about this formula for better understanding, so that you will have a better understanding about this equivalence formulas. You try to analyze this, it's very easy to understand, that's why we are leaving this part. Hope you understand these equivalence formulas. We are going to use these equivalence formulas in our next examples. If you have any questions regarding the concept, please post your questions in the comment section below. Thanks for watching. If you haven't subscribed to our channel, please subscribe to our channel and press bell icon for the latest updates. Thank you.